we've already talked about polynomials. I gave you some very basic definitions. Polynomials where you have two or more terms. The terms are separated by an addition or subtraction sign, okay? These are terms, okay? We got multiplication is not considered a term, okay, by itself. So this 5x, even though 5 and x are being multiplied, combined makes one term, not two terms. The only thing that separates a term is either an addition sign or a subtraction sign. Multiplication and division do not separate terms. Any questions? Okay, so here we go. A monomial is where you have a single term by itself. A binomial is where you have two terms. You can also say that binomial is a polynomial. A trinomial is where you have three terms. You can also say that trinomial is a polynomial, okay? We have practiced how to find like terms. When you have like terms, you have to remember that all of the variables have to be the same and the exponents on those variables have to be the same as well in order for them to be like terms. Thumbs up, Ms. Rez. I'm okay with this so far. Sideways, I'm confused. Please vote. I need to know. Jacob, you finding the okay? All right, here we go. Now we're going to put, before we can start multiplying and doing those things, we're going to put polynomials in order, okay, by degree. All right, so listen. We have two. I already told you what a polynomial was.
You just explained it. I didn't have it written down. Bro, it was. She wasn't.
Just so, okay. When I asked you, you put your thumb in the air. So why do you do that if you don't know?
But I do know. But I just don't want to know.
All right, quarter three. Please stop playing with me. All right, we got page 10. Here we are going to put polynomials in order by degree. Okay, so we're going to learn what a degree is, and we're going to order polynomials. So let's put order polynomials by degree. Okay, so I'm going to tell you how to find a degree of a monomial and then how to find a degree of a polynomial. Okay, by describing what degree is. A degree of a monomial is going to be where you add all the exponents of the variables together. It's the sum of all the exponents. Of variables. Only of variables. So I'm going to we're going to do the first example together. And then once you see that, then you'll probably understand from there how to find degree of a monomial. And a monomial is a single term. So let's do this one together, okay? Let's do this first example together. Raise your hand if you're still writing so I can pause. All right, I will pause for a second. Okay, so now the first one, let's do together. We have this first one. Let's do 6n to the second. All right, so the exponent here is 2 on a variable. So the degree is 2. Degree is 2. Pause for the cause, bless you. Let's do another one. Jay, please stop complaining. We have 8. We got A, B, C. We got C to the third power. We're going to put B to the second. Let's do our degree here. The degree of this monomial You're going to add all the exponents of variables. This is 1, 2, 3, 4, 5, 6. The degree here is 6. I'm going to pause for the cause, let you think about it. The exponent that is automatically on any variable, if you don't see one, is 1. So when you add all of the exponents together, that's 1, that's 3, that's 6.
Oh.
Okay?
Oh,
It's the sum of all the exponents of the variables.
I thought it was like, 5. Yeah.
Okay, let's try another one. Number 3. I'm going to let you try number 3 on your own. Let's do 17. Let's do T Z to the 5th power. What is the degree there?
5.
Robert, what answer did you get? The degree here is 6.
Yeah.
There's automatically an exponent of 1 here. You add all the exponents on the variables together, and that gives you a degree of 6. No, did you see an exponent? T. It doesn't have an exponent, so it's automatically 1.
Yes, so wouldn't it be 7?
Where's the other exponent?
Oh, wait, never mind.
Let's try these. Let's try these. Hush. All right, D'Anthony. The degree here is 12. You add 8 plus 4, that's 12. Number 5. Keon. 4. Yes, the degree here is 4. Great job. Jackson?
14.
Degree here is 14. Very good.
Good job.
Any questions about how to find a degree of a monomial?
No, ma'am.
So now let's find a degree of a polynomial.
Got it right.
For this, you're going to take the highest degree of the monomial. So you're going to find the monomial that has the highest degree, and that is going to be the degree of the whole polynomial. So the degree of the polynomial is the highest or the monomial with the greatest degree.
Oh, you put the twice.
Barletto, please stop.
Yeah, she taught me well, so.
Which is honestly annoying.
Tell him that. Are you calling?
I have
Are you calling Miss Barletto annoying?
both.
You don't like Miss Barletto?
I love her, but it's annoying for people to keep stopping you to correct what you're saying when they know what you mean.
She claims that she got a big book.
Shh.
Yep. She really does.
Yep.
That does my butt look big in these jeans.
She's like,
It does not. She has more. So with this one, you have 3 x to the second, 4, let's do y to the third, and 8. Let's leave it like that. All right, so now let's find the degree of each of these. The degree of this one is what? 2. What's the degree of this? 3. What's the degree of this?
1. 0.
0.
I knew it.
So the degree of the whole thing is going to be 3 because the highest degree is 3. So the degree of this whole thing is 3.
Wait, I thought it was 1. No, it's the highest.
It's just the highest. All right, let's do another one.
More, right?
yes, more right, sir.
Go love.
8 Let's do 81.
Do something.
I'm supposed to put M in. That's okay. All right, so let's do degree of each. What's the degree of this? 5. What's the degree of this? What's the degree of this?
Wait, what?
Which one has the highest degree? The degree of the whole thing is 6.
Wait, bitch, how is that 6?
Bro,
Bro, 5 because the end doesn't have an exponent.
The n doesn't have an exponent. So what's the exponent automatically there?
1.
So when you add 5 plus 1, that gives you 6. All right, try these. Shh. Jerry, please. I'm going to put you out. And you won't have any more minutes with me.
Jerry's honestly thinking about it.
Yeah, please. If you want to leave, go ahead, honey. I will be so happy to not hear that complaining.
Would I get like a write-up on it?
No?
Oh.
I'll write you up tomorrow. I don't feel like it today.
Oh, never mind.
Would I get you out of this class again?
Huh?
Would a writer get him out of this class tomorrow or today?
Yeah, probably.
Probably. Yeah.
I have a lot of those.
Shh. Because you talk too much. Shh. Just be quiet. The complaining is not going to help. What does that do? Nothing. Just slows up the daggone time. And it's disrespectful. I know your parents raised you better than that. Please don't say they didn't.
I'm sorry.
All right. What's the degree of this first monomial?
4.
What's the degree of the second one? What's the degree of the last?
5.
Perfect. What's the degree of the whole thing?
5.
The degree of the whole thing is 5. All right. So now, when you're ordering these, you order them by degree. The highest degree goes first, and then up to the smallest. So which one of these have the highest degree? So this one goes first. That's negative 15, A, B, C to the third. Okay, and then what's the next one?
The first one.
The first one. So that's plus 11, A, B to the third. And then what's the last?
12A.
This, just, yeah, that's fine. This is the, yes, please write this. This is in order. This is how you would probably see the answer choice. You wouldn't see it like this for the most part. You see it like this. This is how you order a polynomial. You order a polynomial from highest degree to lowest degree.
I like these subjects.
I like this subject. You have to really work on basic math.
It is, yeah.
Third grade math.
No, it's not third, no.
It feels like third grade math.
Oh, well, that's good.
Because you just like have to add up the exponent.
All right, so see if you can order this one. 17. See if you can order this. Put this in order. Put this in order by degree. Okay. What's the degree of this one? 5. What's the degree of this term?
2.
What's the degree of this?
10.
And what's the degree of this?
0.
All right, so what's going to go first?
13 A B C to the power 8
Plus.
plus 17 A B C to the power 3 plus 8A squared plus negative or minus 1.
How many people got that right?
I did.
Of course.
Perfect.
I did it in my head, miss.
Good. All right, good deal. So now we're going to multiply. All right, when you're multiplying, of course, when you're multiplying, you're going to use distributive property. There are some shortcut ways that I'm going to show you how to do for some of these, but for the most part, we're going to do distributive property. So we're up to 10 right now, which you'll probably get more, probably. Oh, 9, sorry. I'm sorry. All right, so let's do this one. Let's do number 1 together, okay? So we're going to multiply whatever's on the outside, we're using distributive property, to the numbers on the inside of the parentheses, okay? So this is going to be 6v times 2v. What's 6v times 2v? Yeah, 12v what? What's v times v? Squared. V to the second power. V times v is v to the second power. Now we got 6. Ooh, I need to put my glasses back. I thought I could see it, but I can't. Now we have 6v times a positive 3. What's 6v times positive 3? Positive 18 what? V. Good job. This is my answer here. That's it. That is solving. You cannot combine these terms because they're not like terms. They have to have the same variable and the same exponent as well, okay? Jerry, do you understand that, babe? All right. Wait, Who is that?
Imagine if it's that.
Okay. How many staff? 8. We have one person. This is definitely. All right, so see if you can do number 2, 3, and 4. I'm gonna pause for the calls. Okay, good people, what'd y'all get? Or how would you do number 2? Can somebody tell me how to do that one? Emma, go ahead, babe.
You would do 7 times -5.
Okay, which is what?
-35.
-35.
V.
Oh, V. That's okay, baby. V. And then what?
Do 7 times 8, which is -56.
-56. Raise your hand if you got that right. Perfect. Okay, good job, baby. All right. Number 3. Jacob, good job. All right, so next, D'Anthony. 2x times a -2x. And what does that give you? -4x squared. X times x is x squared. And then what, babe? Minus, you said 6x. Good job. Raise your hand if you got that right. Perfect. Alexander, how you do number 4? Very good. So what does that give you when you multiply -4 times v? And then what do you do after that, babe? And what does that give you? Good job, sweetheart. Raise your hand if you got that. Perfect. All right, so Miss Reyes is going to show you 2 different ways to do the same kind of problem. These are both binomials. So what you do is you can use distributive property or you can use the FOIL method. I'm going to use both, and then you decide from there which one you find to be easier or the easiest to use. Let's use distributive property first because you know how to do distributive property. This is how this works. The first parentheses, you have 2 numbers in the 2 terms in the first parentheses. So you are going to do distributive property twice. You're going to distribute the 2n times 6n plus 1, and you're going to distribute, put the plus 2, you're going to distribute it times 6n plus 1, and then you're going to combine like terms. So let's distribute. We're going to do it twice, okay, because we have 2 numbers in that first parentheses, or 2 terms. So this is going to give you 2n times 6n. What's 2n times 6n? 12n squared. Good job. Okay, what's 2n times 1? 2n. Any questions about that so far? Let's do positive 2. What's positive 2 times 6n? 12n. And what is 2n times 1?
2.
That's 2. What terms can we combine together that are alike? 2n and 12n. When I combine these, what does this give me? So we got 12n squared plus 14n plus 2. This is my answer. So you're going to do distributive property twice. Okay? Try that with number 6, and then I'll show you a shortcut. Okay? If there's 2 terms in the first parentheses, then yes, you must distribute twice. If there were 3 numbers in the first parentheses, then you would have to do it 3 times. I'm going to pause for the calls to give you a chance to do number 6. All right, so let's see. Can someone explain what to do? What are we going to do first? Go ahead, Caitlin.
Hooray! Okay. So you take your 4 and you use distributive property and you multiply it to 2n and 6.
2n plus 6. Good job.
And so you get
Wait. We're going to set it all the way up first, okay, before you start distributing. What else do you distribute besides the 4n?
1.
You distribute the 4. What 1? What kind of 1 is that? Don't forget the positive 1, okay? All right, so now continue. What did you say? What did you do after that?
And then you use distributive property, so you get 8n to the second power. And then you get 20n.
24n. Good job. That's okay. You're fine. Come on, keep going.
And then you get 2n plus 6.
2n plus 6.
6, 1.
Okay.
And then you add like.
And which terms are alike, baby?
The 2n and the 24n.
And what does that give me?
26.
Very good. So that's 8n to the second plus 26n plus what? 6. Raise your hand if you got it right. Perfect. All right, so now I'm going to show you a different method. Shh. If you don't want to use the method, you don't have to. You could just keep using distributive property twice. Okay?
Okay.
All right, so here we go. This other method is called the FOIL method. And FOIL method stands for how you multiply. Shh. Please listen so you can understand. First, outer, inner, last. So in the parentheses, you're going to multiply the first 2 numbers together. So that's x times 6x. What's x times 6x? 6x squared. So that's first. Outer is going to be the 2 on the ends. Okay. What's x times negative 2? Negative 2x. Inner is the ones in the middle. These 2 terms in the middle. What's negative 3 times 6x?
Negative 18x.
Negative 18x. And last are the 2 last numbers on the end of the parentheses. What's negative 6 times negative 2?
Positive 6.
Positive 6. All right, so now, what?
Positive 6.
Positive 6.
Positive 6 belong.
Shh, positive 6. Okay. Somebody say negative? I don't know what they said. All right, it's positive. So now what terms can I combine? What's going to be my answer here?
2x plus negative 2x.
We got 6x squared minus 20x plus 6.
I might use that method.
All right, we're going to try it one more time, okay? And then you decide which one you want to use. You can use the first or the second. It doesn't matter to me. You can only use 4 with 2 binomials. You can't use it with any other type of problem. All right, so I'm going to do it one more time. 4, first, outer, inner, last. First, these 2 first numbers, multiply those together. What do you get? 48 p squared. Good job, Jerry. Outer, these 2 on the ends. What do you get? positive 16p. Enter the 2 in the middle. What do you get?
Negative 12p.
Negative 12p. Last, the 2 on the end. What do you get?
Negative 4.
Negative 4. So now, what's our answer going to be here? Which one? We got 48p to the second. What?
Plus
4p.
Plus 4p
minus.
minus 4. So listen, you use whatever method you want to use. If you want to do distributive property twice, that's easiest to you, please go ahead and do that. If FOIL is easiest to you, please go ahead and do that. There's not one method that I prefer over another. I just want you to use the one that's going to get you the right answer. Any questions?
You said do to 9.
I want you to do till I do one more. Okay, so to use whatever method you want to use, do one more. Okay.